Hello everyone, welcome to SCI-EASE. Have you ever seen a mason making a wall? And from that wall, the room that will be built and the collection of the rooms that will make a building. So what is the smallest unit in that building? That is a brick. So in building, brick is the smallest unit from which that big building that is made up of. In the same way, you have read the chapter, The Fundamental Unit of Life, in which I have told you that cells are the smallest unit in case of body. Plant or animal body, cells, they are the smallest unit. So, what is the smallest unit of matter? That is an atom. So, in this video, I will take up what is an atom. Atom is the smallest part of an element which may or may not exist independently. Okay? So, this is the proper definition of atom. It may or may not exist independently. Mainly, the atoms, they are present in the groups. But some atoms, they can exist independently also. However, these smallest units, or you can say atoms, takes part in a chemical reaction. They take part in a chemical reaction. We have read about what chemical reaction is. So atoms, they take part in a chemical reaction. Now the next question is, how big are atoms? Can we see them? You know that brown ant, that is very small. Sometimes we can't see it. It's very small. So I have told you that we can't see it with the naked eye. This means the atom is smaller, very smaller than the ant even. Okay? So, you know bacteria, they are very small. E. coli and other bacteria, they are very small. And they can be seen under the conventional microscope. But you know, we can't see atoms under the conventional microscope. We can see atoms only under the sophisticated microscope, which is known as scanning tunneling microscope, that is STM. So only under the powerful microscope we can see atoms. So atoms, they are very, very small. Sometimes the question arises that why we bother about such a small thing like atom? But we know that atom, it forms matter, which is all around us. So, some magnified images of the clean surface of the silicon, that is taken by the scanning tunneling microscope, STM. Okay, that diagram is given in your book in blue color. You can see that how the image, very magnified image of clean surface of silicon is taken. Now the next thing is, what is the shape of an atom? I have told you, already I have told you that atom is spherical in shape. So how its size that can be measured? We measure the size of the circle. How we measure the size of the circle? we take a center and then we draw a line up to its periphery, or you can say circumference. So this much, that is the radius of a circle, that is the size of the circle. In the same way, I have told you that atom is spherical in shape. So its atomic radii, that will tell us the size of an atom. What is atomic radii? Suppose this is a nucleus of an atom in which proton, which are positively charged, and neutron, which have no charge, these two particles are present. Around this nucleus is the extranuclear region, or you can say shells, in which the electrons, they revolve. So in first shell, the maximum number of the electrons it can accommodate, they are 2. In the next shell, suppose it has 1 electron. Okay? So how we can measure the atomic radii? Because I have told you that the size of an atom, that is expressed in terms of atomic radii. We will take a center of the nucleus and we will draw a line up to the shell which has, outermost shell you can say, which has electrons in it. Okay? So this is the atomic radii and it will give us the size of an atom. So this much thing must be clear, that the atoms, they are spherical in shape and their size, that is measured in terms of their atomic radii. And how atomic radii they can be measured, that I have told you. If it has 3 shells, then from the center to the third shell, the atomic radii of that atom will be. Okay. So I have told you that atoms, they are very, very small. They can be seen only under the very powerful microscope. So this means that this length, you can say the atomic radii, that can be expressed by a very small unit. Otherwise, if we measure the radius of the circle, we measure in centimeters, or if it is a big circle, then in meter. But here, it's very small. So the term here, or the unit you can say used here, they are nanometers. What do you mean by nano? Nano means small. You must have seen a nano car. It's a small car. That is why its units, they are known as nanometer. So atoms, they are so small in size that their radii, they are expressed in nanometer, symbol Nm. Okay. So what is the relationship between meter and nanometer? That I am going to tell you. 1 nanometer, that is equal to 10 to the power minus 9 meters. Okay? Or in other words, you can write it like this. 1 nanometer is equal to 1 over 10 to the power 9 meters. So we have read about what are atoms. I have told you the definition. You should know it because they are the building blocks of all matter. Then I have told you that what is their size, how small they are, and how we can see the atoms that I have told you, and the units in which the atomic radii, they are expressed. That is the nanometer, and the relationship between meter and nanometer I have told you. Now next is symbols of atoms of different elements. You know that to write very long names of the elements. It is very tough, and also that name, it does not provide any information to us. So the scientists, they thought that some symbol, this word, this idea, first of all, it came in the mind of Dalton, John Dalton. I've told you that some symbols should be given to these elements. So he gave some symbols like to hydrogen, like this, then carbon, circle with shade, oxygen, only circle, phosphorus, like this, and sulfur, plus sign in the circle, copper in the circle C, lead, L in the circle, and silver, S in the circle. But these symbols, they are not appropriate. Scientists thought that there should be some other shorthand notation for the elements, for the names of the elements. So Berzelius, he gave his idea that symbols should be made from one or two letters of the name of the elements. Why one or two? You know that we have 118 elements in the periodic table. 118. And in English, we have only 26 alphabets. So we can't name the element with its starting letter. Some elements like copper, chlorine, chromium, okay, these all, they start from C. How can we give carbon? How can we give the starting letter only to these elements? So firstly, it was observed that some symbols, they are given from where that element that was discovered, from the place where that element that was discovered. Like in the case of copper, it was discovered from Cyprus, okay? And in some cases, by studying its property, like gold, it's yellow in color, so its symbol that is given accordingly. But later on, IUPAC system, IUPAC, International Union of Pure and Applied Chemistry, they gave the symbols of these elements by selecting the first letter and the second letter or the second letter to the elements. But in some cases, instead of second letter, the third letter that is also used. Like you take the case of zinc. In case of zinc, Zn. So the third letter that is taken up. In the case of chlorine also, chlorine, then Cl, that is the symbol, okay? So in accordance with, like I can write, first is hydrogen. Hydrogen has symbol H. Helium, He. This thing you must take into consideration, that the first letter should be capital and second letter it should be small. He shouldn't be like this. It's wrong. Okay, it should be small letter. Third, lithium, Li. Then beryllium, Be. Boron, B. Carbon, C. Okay? Nitrogen, N. Oxygen, O, fluorine F, neon Ne. Okay, so the symbols, they are either from the starting letter or from starting letter like this, or it is the combination of starting letter or first letter or any other letter which is in the name. Okay, but some symbols, they are from the Greek, Latin or German words. Okay, like you can take the case of iron. Iron has symbol Fe. It is from the Latin word ferrum. Okay. Then sodium, potassium, they are also from the Latin word, potassium from kalium. Okay. So the symbols, they may be from the starting letter that I have told you. They may use first letter and the second letter or any other letter which is in the name, like I have taken the case of zinc and chlorine. Then the symbols, they may be from the place from where they are discovered, or the symbols, they are from the Latin or the Greek words also. So the various symbols, you should memorize the symbols starting from 1st to 20 atomic number. That should be on your tips. Name of the, like I have taken up to 10, I have taken hydrogen H, helium He, lithium Li, beryllium Be, boron B, carbon C, nitrogen N, oxygen O, fluorine F, and neon Ne. So up to 10 I have told you, then 11 from sodium, sodium is Na. Okay, up to 20, 20 is calcium Ca, C capital, A small. Up to that, you must memorize it, the symbols, because when we will form a molecule from these elements, then if you know the symbol, then and then only you can write the formula of, chemical formula of the molecule. So I have told you enough in this video. I have told you about atom, its size, and then its symbol. Okay, so go through this video, and apart from this, you must memorize the symbols of the elements from atomic number 1 to 20. That should be on your tips. I will come with the next topic, that is atomic mass. I will take up in the next video. Till then, thank you very much.